Okay, geometry fans, today we're going to start with talking about circles, and this is going to be kind of an overall introduction to circles. First of all, your geometry joke of the day. So the question is, what did the 0 say to the 8? And the answer is, nice belt. Okay, so we're going to start with talking about parts of a circle here. The first thing is really kind of a basic question. What is a circle? Now I know you can describe it. You'd probably say things like it's round, 360 degrees, no straight lines, things like that. But actually, what is the definition of a circle? Well, the official definition, okay, over here on the side, a circle is the set of points equidistant from one point. Okay, if I take one point, and in this case I'm going to call it P, right here, and then I take a measurement, and I measure the same distance all the way from P. I do this multiple times. I keep getting points and more points. All the points that are the same distance from this one point P, this is the circle, right here. This whole thing here is a circle, where the center is point P. Now the way that we name this, the way that we write this, and we'll do this over here on the side, is we draw a picture of a circle, we put a point in the middle, and then we name that center. So that is the circle with center at P. So when you see this, that point, that vertex, okay, that is your center right there. Okay, so some other vocabulary terms, different kinds of segments in a circle. Okay, one is called a diameter, which I'm sure you're familiar with. The diameter is a segment with two endpoints on a circle that goes through the center of the circle. So if you take the center here, P, and we draw a segment that has both of its endpoints on the circle, so C and D, for example, and we connect those, if it goes through the center, then this is what we would call a diameter. All right, so this whole thing here, CD, let's just use the letter D for that. That is a diameter. So we could name it on the side. A diameter is a segment. So to name a segment, we use the 2 points, and we put a segment bar above it. So there's diameter CD. Now, another type of segment is called a chord. A chord is a segment with two endpoints on the circle, but it doesn't necessarily go through the center. So if you look at your picture, you have AB has two endpoints. Both of these are on the circle, and then the segment between them that connects those, that is what we call a chord. All right, so that's a chord right there. So you could say on the side here that segment AB is a chord, but there's also another chord in the picture. A chord does not have to go through the center, but it can. So actually a diameter like CD is also an example of a chord. It's just a special type of chord, and we give it a different name. We call it a diameter. Now another segment that you're probably familiar with is radius. So the radius starts at the center, it goes to one point on the circle, so basically it's half of a diameter. So it's a segment that goes from the center to a point on the circle. So if you look at your picture here, well, let's see. You have a radius from P to F. PF is a radius, but then you also have, so we could call that R for radius. You have two more radii. Radii is the plural. From P to D, there's a radius. And then from P to C is a third radius. So we actually have three of these. So the radius, we could say PD. We could say PF. And then we could say PC. Those are all radii. Now the other thing that's true for a radius is that in a circle, all of these have to be congruent. They're all the same length. because they all start at the center, and a center is all the points that are equidistant, that are the same distance from that central point. So any radii in a circle, they're all going to be congruent. Now there are two more types of segments. These are actually lines here, and these are ones that you may not be familiar with. The first one is called a secant. A secant is a line that intersects a circle in two places. In two places. Well, you have a line here. We have line AB. Now notice that if you only connect A to B, what you have is a chord. So if you're only talking about the segment, that's the chord. But if you talk about the line itself, that is what we call a secant. So when we name the secant, let's go ahead and use a line symbol, AB. Now you could also say BA, line BA. So that is a secant. So over here, let's draw a little arrow there and write down the word secant. And then the last thing is what is called a tangent. Now you talked about tangent with right triangles with SOHCAHTOA. This is a totally different idea. Okay, this is a different kind of tangent with a circle. A tangent is a line that intersects a circle in exactly one place. Okay, so a secant goes through in two places, but a tangent only goes through in one place. And if you look at the circle, up here, you have a line, but the only place where it intersects the circle is at point E. So this right here is a tangent. Okay, so the tangent line. And you can also have, you can have a tangent segment, you can have a secant segment, but for now we'll just talk about lines. That would be line GE. So it hits the circle at point E, but then that's it. It shoots off past it. It only hits it in one point. So that's going to be line GE. Okay? So those are all parts of a circle. We will be using this vocabulary as we go through this chapter. Now for the next couple days though, we're going to concentrate mostly on angle measure and arc measure. One of the things that you probably know about a circle, okay, I'm just going to draw one here, doesn't need to be perfect, is that 360 is a common number with a circle. All the arc measure of a circle always adds up to 360 degrees. And now if we put a center here, and we'll call this, let's just say this is A. So this is the circle with center at point A. That's how we would name that circle. One thing that happens is that if we draw some radii, we'll go there, and we'll go there. And let's just draw one more segment here, one more radius. Okay, so there's the center at A. Now we just created 3 angles. Let's go ahead and call those angles angle 1, angle 2, angle 3. One of the things that's always going to be true, okay, when you talk about triangles, you talk about the number 180 degrees when you add up all the interior angles. Well, with a circle, we're going to be talking about 360 degrees. If you add up all 3 central angles, you always get 360. So when you add up all the central angles, it doesn't matter if there's 3 of them, 5 of them, 10 of them, all the central angles always add up to 360. So we'll say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals 360 degrees. That's always true for any circle. So that is central angle measure. Okay, so all of these, I'm going to draw an arrow here. That is a central angle. Central angle. And what that means is that the vertex of your angle is at the center. The vertex of the angle, the point, is at the center. That is a central angle. Okay, now we're also going to talk about what's called arc measure. And there are some definitions for this. Okay, we're going to talk about arc measure. You have different kinds of arcs. So for the first one here, I'm going to draw a circle. I'm going to leave a little bit of space here at the top because we're going to write some things down. Let's put the circle down here. Let's go ahead and put a center in here. Let's call it P. All right, we'll name that with P. So this is the circle with center at P. And let's go ahead and draw an angle. Now, if you trace out this angle, let's say the angle is 75 degrees. Okay, so the angle is 75. I'm going to move this up a little bit here. So the angle is 75. If I go from the vertex and I copy the side, if I trace it out, I'm going to hit the circle in two places. I will intersect the circle here, and I will also intersect here. Now let's call those 2 points A and B. Okay, so there's A and B. Now notice that there's an arc between A and B. The arc is the curved part of the circle. Okay, so the angle is angle APB. But the arc here is what we call a minor arc. Okay, this is called a minor arc. And there is a rule that says that the measure of a minor arc is always equal to the central angle measure. So the central angle is angle APB at the center, 75 degrees. The arc measure is going to be the same thing, it's 75. So what we're going to write down here, the measure of the minor arc is equal to measure of central angle. Is equal to the measure of the central angle. If the central angle is 75, then the arc measure is 75. The way that we write this down, the way that we would write this down is we would say measure, little m, measure of arc AB equals 75 degrees. That's how you would name the arc. That's how you would write it down. So the measure of the central angle, measure of angle APB is 75 degrees. The measure of the arc AB is 75 degrees as well. So that is what we call a minor arc. A minor arc is always, okay, we'll also put this here at the top. Minor arc is always less than 180 degrees. Less than 180 degrees. Okay, let's add one more point on the circle. Let's put it over here. We'll call it C, point C. When you look at the arc, okay, points A and B and the arc between them, well, you have a minor arc, but did you notice that if we went the other way, let's say we went from A to B, but we went counterclockwise in this situation. So we went from A to C to B. That's a different kind of arc. Minor arc is less than 180. If you are more than 180 degrees, this bigger arc, we call this a major arc. Okay, so this one, the green one, is a major arc. So for a major arc, we're going to say it is greater than 180 degrees, okay, for a major arc. And the other thing that is the way that you can calculate this, you know that all the arc measure is always 360. The central angle measure is always 360. The arc measure is always 360 degrees. So if you know the minor arc is 75, if this is 75, then this is whatever's left over. So to calculate this, you do 360 minus the minor arc. And in this case, that would be 360 minus 75. And that's going to give us, let's see, 10 minus 5 is 5. 15 minus 7 is 8. We get 85 degrees. The way that we name this, we would say the measure of arc. If it's a major arc, you have to use 3 letters. So you'd start with A, then you go to C, then you go to B. ACB. You have to travel the circle in the order that you write this. So ACB. that is the major arc, equals 85 degrees. So that's the major arc. The minor arc was 75. Now the last one, okay, we'll draw a new circle here. If you have a semicircle, a semicircle is half a circle. Okay, so let's assume that that is the center again. If this is a diameter, okay, if we call that D for diameter, it's going to cut the circle in half. So what that tells you is that the top half is going to be 180 degrees, and also the bottom half is going to be 180 degrees. Okay, so the top half is 180, the bottom half is 180. So if a major arc is greater than, this should be greater than 180, and a minor arc is less than 180, then the measure of a semicircle is always equal to 180 degrees. Okay, so that is the first side of the notes. So what we'll do, turn it on to the back, and we'll write down one more theorem, and then we'll also look at some examples.